Irrational numbers, the third exercise of this chapter. Let's discuss the points to remember. What are co-prime numbers? Any two numbers whose highest common factor is 1 are said to be co-prime numbers. For example, 15 and 22. Though 15 and 22 can be factorized, but they don't have any common factor. So these two numbers are co-prime numbers. Next, consider a rational number and an irrational number. The addition of rational and irrational is always irrational number. Similarly, the difference of rational and irrational is again irrational. Product of a non-zero rational and irrational is also irrational. Similarly for quotient, means division. Now let's discuss theorem 1.3. What it states: let P be a prime number if P divides the square of an integer, say a square, then P also divides a. For example, if you consider 5 divides 25. So 5 divides 5 also. Next, theorem 1.4. It states that root 2 is an irrational number. So with this data, let's start exercise 1.3. First example, prove that root 5 is an irrational number. Such examples can be proved by contradiction method. Let us assume that root 5 is rational. As we had considered this to be rational, it must be written as a by b, where b is not equals to 0 and ab are co-prime numbers. So this implies that root 5 into b is a. Squaring both sides, 5b square equals to a square. Let this be equation 1. This says that a square is divisible by 5. So by theorem 1.3, a is divisible by 5. Now as a is divisible by 5, we can write a as 5 times some constant. Say a equals to 5k for some integer k. Squaring both sides, a square equals to 25k square. But from equation 1, what is the value of a square? It is 5b square equal to 25k square from equation 1. This implies that b square is 5k square. B square equals to 5k square means what? B square is also divisible by 5. It means b is divisible by 5. That is, both a and b are divisible by same number 5. This contradicts to the assumption that A and B are co-prime numbers. It means root 5 cannot be expressed in the form of A by B. Hence, root 5 is an irrational number. Question number 2. Prove that 3 plus 2 root 5 is irrational. Again, by contradiction method, we will prove this. Let us assume that 3 plus 2 root 5 is rational. So let 3 plus 2 root 5 be of the form A by B, where A and B are co-prime numbers. From this 2 root 5 is A by B minus 3. Taking LCM, so B will be the LCM, A minus 3B. So this implies that root 5 is A minus 3B upon 2B. Since A and B are integers, A minus 3B upon 2B is rational. That is, root 5 is rational. But this contradicts that root 5 is irrational. Therefore, 3 plus 2 root 5 is irrational. Similar type of question. Question number 3. Prove that the following are irrationals. I will solve example 1. Second and third you try yourself. To prove that 1 by root 2 is irrational. Assume that 1 by root 2 is rational. Let 1 by root 2 be of the type A by B, where A and B are co-prime numbers. That is, root 2 equals to B by A, taking reciprocals. That is, root 2A equals to B. Squaring both sides. So 2A square equals to B square. Let this be equation 1. It means B square is divisible by 2. So by theorem, B is divisible by 2. So we may take B equals to 2 times some integer, where K is integer. Squaring both sides, B square will be 4K square. From equation 1, B square is 2A square equals to 4K square. It means A square is 2 into K square. So what this implies? This implies that A square is divisible by 2. Again by theorem, a must be divisible by 2. That is, both a and b are divisible by 2. This contradicts. To our assumption that a and b are co-prime. Hence, 1 by root 2 cannot be written in the form of a by b. Hence, 1 by root 2 is not rational. Hence, 1 by root 2 is irrational. So, this completes exercise 1.3. Thank you.